discussed about properties of transaction. Those are ACID properties: atomicity, consistency, isolation, durability. We have discussed these with the examples. After that, we discussed about the transaction states. Those are 5 states: start state, partially committed state, failure state, and aborted state. And after that, we discussed about the techniques. Okay, shadow copying technique. So that means what? While you are doing transaction, so we can maintain one copy of the transaction before doing any manipulation. If manipulation successful, then new transaction we will do. Otherwise, if you have any problem while your transaction, we will do undo operation. Okay, rollback operation. That means we will go back to the transaction. That is called copy transaction. We discussed already. And after that, we implemented durability and among the database using recovery manager and logs. Logs means whatever transaction you are doing, that failure, whatever happens, that all the logs means messages, transaction failure, success, all the data we can maintain in the logs file. This today's session we are going to discuss about the concurrent execution. We are going to discuss about concurrent execution in that transaction schedules. So schedule, here 2 types of schedules we have: serial schedule or serializable schedule, or concurrent schedule. 2 types of schedules will there. After these topics, we are going to discuss about serializability. 2 types of serializability: conflict serializability, view serializability. In the conflict serializability, these are the topics: conflict equivalent, conflict serializable, and conflict operations. Like for doing operation to different transactions, so we will discuss. After that, we are going to discuss rules for conflict serializability. Rules we will be discuss. Okay, see what is concurrent transaction. See here, executing a set of transactions simultaneously, that is called concurrent transaction. Concurrent transaction means what? Executing a set of transactions simultaneously in preemptive and time sharing methods. In database management system, concurrent execution of transaction can be implemented with interleaved execution. Transaction schedules, we have schedule, right? So for doing schedule, here schedule refers to the list of actions to be executed by transaction. For doing transaction, we'll do list of executions, right? So here schedule means refers to the list of actions to be executed by transaction. A schedule is a process of grouping the transactions into one and executing them in a predefined order. We are executing in predefined order. We are executing group of transactions one by one in predefined order. Here, schedule of actions can be classified into 2 types. First one is what? Serializable schedule or serial schedule. Second one is what? Concurrent schedule. Here, serial schedule means in the serial schedule, the transactions are allowed to execute one after another, ensuring correctness of the data. A schedule is called serial schedule if the transaction in the schedule are defined to execute one after another. Okay, one after another element is schedule in the serial schedule. The concurrent schedule means concurrent schedule allows the transaction to be executed in interleaved manner of the execution. Concurrent, serial schedule and concurrent schedule we discussed. See, complete schedule. For example, it is a schedule of transaction where each transaction is committed before terminating. Here we will see one example. Assume like we are doing T1 and T2 transactions. T1, T2 terminates after committing the transaction. If you commit it, then it is going to terminate it. First, how we can do? First, we will take one T1, T2, two transactions. First, in the T1 transaction, in the account we have 1000 rupees. So we read the 1000 rupees, and after that we are going to add 100 rupees to that. Then we are going to write. Okay. In T2 transaction, we are reading the amount. Okay. After that, we are storing that amount in one variable, and we are subtracting 100 rupees from B account. Okay, and we are writing that amount in that T2 transaction. So if T2 transaction completed, then only we can perform commit operation. Commit means we are permanently saving the all the changes. Okay, after that, in T1 transaction, read the B value and write the B value, then doing commit. Okay, finally we are saving all changes. So in that way we need to do in serial schedule. Here we need to discuss about serializability. What is serializability? See, you are doing partially parallel transactions, right? In isolation, we are doing parallel transactions. Okay, where here we should use the serializability. Serializability here, a transaction is said to be serializable if it is equivalent to serial schedule. Serial schedule. One transaction complete, then only another transaction will going to be allowed. So serializable accepts are two types here now. Serializability. Conflict serializability, view serializability. Two types, right? Conflict and view serializability. Conflict serializability. Conflict serializability means a schedule is conflict serializable if it is conflict equivalent to some serial schedule. Here conflict equivalent, conflict serializable, and conflict operations we will see in the serializability, conflict serializability. So conflict equivalent, when we can say conflict equivalent, when two schedules are said to be a conflict. Okay, conflict equivalent, conflict equivalent when one can be transformed to another by swapping non-conflicting operations. Coming to conflict serializable, a schedule is called conflict serializable if it can be transformed into serial schedule by swapping non-conflicting operations. Coming to conflicting operations, two operations are said to be conflicting if all below conditions are satisfied. What are the conditions for conflicting operations? For doing conflicting operations, first thing is they belongs to different transaction and they operation on same data item, and at least one of them is a write operation. One of them is as write operation. So what are the operations? So for conflicting operations, two operations are said to be conflicting if all below conditions are satisfied. That means the below conditions are they belong to two different transactions and they operation on the same data item, and at least one of them is write operation. At least one of them is write operation. That means two conflict operations have to be a conflicting. Here conflicting means what are the operations they should be satisfied? First thing, they belongs to different transactions and they operation on the same data item, and at least one of them is write operation. Okay, if it refers to two instructions of the two different transactions may want to access same data to perform read and write operation. Read or write operation. Okay, so what are the rules of conflict serializability? So we have some rules, right, for doing conflict serializability. See what are the rules. Three rules, mainly three rules here. So first one is if two different transactions are both for read operation, then there is no conflict and can call allowed to execute any order. That is going to allow to execute any order. Okay, if one instruction performing read operation and other instruction performing write operation, then there will be a conflict. Hence, instruction order is important. Instruction order is important here. Coming to third one, if both transactions performing write operation, then there will be a conflict. So order the transaction can be done. Order transaction can be done. So these rules we follow for the conflict serializability. Read write first both read operation. If the conflict occurs, what happens? If one read operation, one write operation, then finally both write operations if you perform one conflict occurs, so the order transaction can be done. These are the rules. Okay, coming to view serializability. Last one is what? View serializability. In the serializability, second one is what? View serializability. Here view serializability means, so this is another type of serializability that can be derived by creating another schedule out of an executing schedule. Sorry, out of an existing schedule. So view serializability is the type of serializability, another type of serializability that can be derived by creating another schedule out of an existing schedule. A schedule is a view serializable if the schedule is view serializable, if it is view equivalent to some serial schedule, every conflict serializable schedule is view serializable, although the converse is not true. The converse is not true. Two schedules. We have two schedules like S1 and S2. Here S1 and S2 over the same set of transactions. Any transaction that appears in either S1 or S2 must also appear in the other or view equivalent under this conditions. Here conditions, we have three conditions. First, if Ti is one read the initial value of object A in S1. Okay, here two schedules now, S1 schedule and S2 schedule. Here T is transaction. So Ti reads the initial value of object A. Here A is a object. So Ti reads the initial value of object A in S1 schedule. So it must also read the initial value of A in S2. If you are performing operation in S1, you must read the initial value of A in S2. Next condition in view serializability. Now the next condition, second condition is if Ti reads the value of A written by Tj in S1 schedule, it must also read the value of A written by Tj in S2. Third condition, for each data object A, the transaction that performs the final write on A in S1 must also perform the final write on A in S2. Okay, these are mainly three conditions we need to follow for view equivalent. Okay, see view serializability. The above two schedules are view serializable or view equivalence. The transaction is both schedules performs the action in the similar manner. The above two schedules satisfies the results view equivalence if the two schedule produce the same result after the execution. For example, if you are performing these all operations in S1 schedule, read operation R1 of A object, write operation W1 of A. If it is read operation 2, R2 of A of write operation, W2 of A is the object here, A, B are the objects. So now we are performing read operation, write operation. So first read operation R1, second read operation R2. Okay, and first write operation W1 and the second write operation W2. Here the example we can say R1 of A, W1 of A, R2 of A, W2 of A, R1 of B, W1 of B, R2 of B, W2 of B. So view of serializability one by one. The thing is anomalies. Anomalies due to interleave execution of transaction. Anomalies. After these rules, we are going to discuss anomalies due to interleave execution of transaction. What are the problems we are facing? See here. Due to interleaved execution of transaction, the following anomalies can occur. What are the anomalies here? Three anomalies we have. Three anomalies for interleaving execution of transaction due to interleave execution of transaction. First anomaly, reading uncommitted values. Reading uncommitted values. Here WR means write read conflicts. Next, unrepeatable reading data operation. Unrepeatable reading data operation. Here read write conflicts. Next, overwriting uncommitted data. Write write operation. So overwriting uncommitted data. These are the three anomalies happening due to interleave execution of transaction. So how it will be? For example, see here we have transaction T1 and T2. See, reading uncommitted values. Write read conflicts. If you try to read the value which is not written on to the database, that means not committed, so will leads to write read conflict, which is called dirty read operation. Also called as dirty read operation. Also called as dirty read operation. If you try to read the value which is not written onto the database, so it will leads to write read conflict. Write read conflict. This write read conflict is called dirty read operation. Okay. See here example. Of T1 and T2, two types of transaction. Two transactions here. In T1 transaction, we are reading a object, okay, and writing a object. See here, what we are doing? Write read conflict means dirty read operation. Write read operation conflict. Write read conflict. See, we are reading object A in T1 transaction, then writing object A. From T2 operation, we are reading object A and writing object A. Then we are reading object B and writing object B, then committed. In T1 transaction, reading B object and writing B object and committed. So this is called reading uncommitted data. Here we are reading uncommitted data. See, in this above example, T1 write operation on data item A is not committed, but it is being read by T2. Being read by T2. It is not committed, but it is reading by T2. So reading an uncommitted data will lead to inconsistency in database. Okay, it is making inconsistency in database, which is called dirty read operation. That's we call as dirty read operation. I think you understand, right? The second one is what? Second one is unrepeatable reading data operation. So read write conflict. Read write conflict. Here, reading the same object twice before committing the transaction might yield an inconsistency. Okay, so read then write. So that is a read conflict. Write after read. So that is unrepeatable reading data operation. Here, unrepeatable problem means we get different values in different reads. For example, in S1, say T2 read initially x equal to 5, then T1 updated x equal to 1. So now T2 will be read x equal to 1. Here T2 has read two different values during the consecutive reads. This should not have been allowed as T1 has not committed. Okay, that is called read write conflicts. Read write conflicts. Third one is what? Third one is overwriting uncommitted data. Overwriting uncommitted data. Overwriting uncommitted data. Here, write write conflicts. Here we can get write write conflicts. Write write conflicts. If one transaction could overwrite the value of an object which has been already modified by another transaction while first transaction still in progress, this kind of conflict referred to blind write conflict. This is also called as blind write conflict. Blind write conflict. This is also called as blind write conflict. Okay. Overwriting uncommitted data, that is write write conflicts. So write write conflict, if one transaction could overwrite the value of an object A which has been already modified by another transaction while first transaction is still in progress, this kind of conflict refers to a blind write conflict. Okay, these three are anomalies due to interleave execution of transaction. Due to interleave execution of transaction. Okay. Next topic, recoverability. Recoverability. See, recoverability refers to process of undoing the changes made to the database in case of any transaction failure due to system crash or any other. We are going to recoverability process is undoing the changes. We are undoing the changes made to the database when in case of any transaction failure due to the system crash or any other reason. Okay, so recoverability schedule. In recoverability schedule, what we are going to be do? So based on whether recovery of failure transaction schedule are classified as three things. Is classified as ways. First one is irrecoverable schedules. You cannot recover it. Second one is recoverable schedules with cascade rollback. We can recover by using rollback operation. Third one is cascade's less recoverability. We can recover, but it is less. Those three are recoverabilities. We will see one by one. Okay. This all of you are getting this recoverability schedule classified into three ways: recoverable schedule with cascade rollback, cascade-less recoverability. Okay, these topics we'll discuss in tomorrow class. Okay, so this till what we discussed. Okay, in the concurrent transaction management, today's topic, our topic is concurrent execution. In that we discuss transaction schedules. Here schedule, two types of schedules we have: serializable schedule or serial schedule, then concurrent schedule. And after that, serializability. In serializability we have two types of serializability: conflict serializability and view serializability. In conflict serializability, we discussed the conflict equivalent to conflict serializable and some conflict operations. Okay, after that we discuss rules for conflict serializability. Okay, after that we have some anomalies. We are getting some anomalies due to interleave execution of transaction. Okay, those are the three. First one, reading uncommitted values while performing write read operation. We are getting conflicts, that also called as dirty read operation. And after that, second anomaly is unrepeatable reading data operation. That is read write operation. While doing read write operation, we are getting conflicts. So that is unrepeatable reading data operation. Next, third one, overwriting uncommitted data. That is write write operation. So that is also called as blind write conflict. We have one example here. We can see after before committing the T1 operation, we are committed. We are reading data in T2. Okay, reading object T2. So this was the conflict from the reading uncommitted values. So while doing write read operation. So how we can recoverable? So by using recoverability. So when we can recover means, so irrecoverable schedules, recoverable schedules with cascade rollback, cascade less recoverability. In three ways we can recover. First one, irrecoverable schedule. Some data we cannot recover, and the recoverable schedule with cascade rollback. By you doing rollback operation, so some schedules we can recoverable, and the cascade less recoverability means we can recover not all the data. So that is called cascade less recoverability. We will see these topics with examples in the next class. Till this, try to understand the topics, then only you can understand the remaining topics. Okay, transaction management is easy. If you read once also, you can understand these topics. Okay, I will share this document in Teams. Okay, see once, try to understand, try to solve some examples like the read and write operations. Okay.